So we are working on this graph. Fx is equal to the absolute value of 3x. Okay, so let's make a table and let's mark a few things. So we can take any number of values. So let's take -3, -2, -1, 0, 1, 2, and 3. And let's draw this graph. So if I put in a -3 in place of x, I'll get -9. And then when I take the absolute value, I get a +9, which will live in a curve when I put in 3. Same with -2. 3 times -2 is -6, but we want the absolute, so that's 6. And 6 over here. And then this would be 3 and 3, and this would be 0. Now let's plot these. We have 1, 2, 3. So at -3 it's 9. At -2 it's 6. At -1 it's 3. At 0 it's 0. At 1 it's 3. At 2 it's 6. And at 3 it's 9. Now we use a ruler and draw the line, we'll get a graph of this sort. This is our graph for fx is equal to 3x and the absolute value. Now they've got two other things. So they're saying that there's a second graph gx, which is fx minus 2. Now what does fx minus 2 mean? It just means that all these values over here are subtracted by 2. So this will become 7, this will become 4, this will become 1, this will become 1, 4, and 7, and this will become -2. So let's plot these. So at -3, I'll use a different color. It's 7. At -2, even at +3, it's 7. And then I've got at -2 I have 4, which is over here. At 2 I have 4. At -1 it's 1, and at 1 it's 1, and then at 0 it's -2. So let's put that. So this is all gx, this part. I'll shade it in blue so that you have an idea where we are. So this graph is gx, which is fx minus 2, or in other words it's 3x modulus minus 2. So this is our second graph. So we got this done. Then there's a third part. Let's use a different color, maybe green. So this one's, if I have hx is equal to fx minus 4, right? So basically that is, so we try to plot this. hx is equal to absolute value of 3x minus 4. So if you put this in your graphing calculator, so if you made this table, this is what we end up getting. So x and hx. So if we did -3, we get 13. If we do -10, we get 10. If we do -1, we get 7. And then I'll put the other values over here. So if I do 0, I get 4. Then 1 is 1. Then 2 is 2. So let's plot these. At 0, it's 4. At 1, it's 1, which is over here. At 2, it's 2. At -1, it's 7, which is up here. -2 is 10, which would be up here. So let's plot this. So this graph, the green one, is hx. So there are 3 graphs on the same graph. Put this in your graphing calculator. Yeah, I drew the graph on Desmos. You can use your calculator to solve this. Okay, so now we've got the two functions. Y is equal to x minus 3 and 3x plus 3y is equal to 27. Now they are graphed on the same set of axes. Which statement is true about the solution of the system of equations? So the two graphs, the blue one is 3x plus 3y is equal to 27, and the red one is the absolute value of x minus 3. Now where do they intersect? At 6 and 3. So that's what we are looking for. So it cannot be number 1. That's not the solution to the system. 9, 0 is not the solution either, so cancel 1 and 2. Now 3 is possible because it is the solution of the system of equations. And then look at 4. 3, 0, 9, 0 and 6, 3 are the solutions. So are all of these the solutions of the equation? This is the y-intercept for this. This is the y-intercept for this graph, right? It's not the solution. The solution is only this value where they intersect. When they ask for the solution, they're asking, hey, where are these graphs intersecting or meeting? Okay, so 3 is the answer choice. And you can plot these graphs on your calculator and see where they intersect and find that point. Alright, so we've got to draw two graphs. Now remember this piecewise function or graph. So before 1, this part, before 1, it follows this graph. Fx is equal to absolute value of x. After 1 till 8, imagine this to be like maybe time. Before 1 p.m. you're following a certain pattern, and then after 1 p.m. you're following a different pattern. So after 1 p.m. you're following this, that fx is equal to 4. So it doesn't have a a dependency on x. It's just going to stay consistent at 4. So let's put in 4 for all these values. Okay, let's try marking our axes. And these are over here where the grid lines intersect. Let's mark some negative points. Okay, so if we were to plot this, it's always 4. So let's do it in blue because I wrote it in blue. So 1 is 4, 2 is 4, 3 is 4. And for a straight line, you need a minimum of 2 points. So you don't need to show all these points, but even if you were to show these points, this is your graph. And this point would be shaded. These are all inclusive, so I'll shade all of them. So when you have a sign like this with the equal, this is inclusive. Both of these are inclusive. This one, on the other hand, is not included or inclusive. So we'll show an unshaded point. Okay, so let's do the second part. So fx is equal to absolute value of x. Let's put in these values till 1. We'll show the extreme, but we'll show that it's not included by showing an unshaded point. So if I were to put -3, I get 3, -2 becomes 2, -1 becomes 1, 0 becomes 0, 1 is still 1. So let's plot these. So this is included, this is included, this is included, this is included, but this last point is not included. So let's draw the line through these points. So this is fx is equal to the absolute value of x till 1, and then this is fx is equal to 4, which is onwards. Alright, so let's try to draw this graph. Y is equal to absolute value of x minus 3. Again, because it's choose any values for x. I'm choosing a number of values here so that I can get that V shape. Remember, you want to show the distinctive shape of the graph. If you don't show it, you'll won't get full points for it. So if I were to put -3, I'll get -3 minus 3 and the absolute value. So that's the absolute value of -6, which becomes 6. Then -2 minus 3 will become -5. Absolute value is 5. Then you'll get 4. Then you'll get -3, but the absolute value is 3. Then you'll get 2. Then you'll get 1. Then you'll get 0. Then you'll get 1. Okay, and if you were to go ahead, you'll get this point. And there you see that V-shaped graph. So we plot all of this. So at -3 it's 6, at -2 it's 5, then it's 4, then it's 3, then at 1 it's 2, 2 it's 1, at 3 it's 0, at 4 it's 1, 5 it's 2. So you get that V-shaped graph. So let's draw this line. So y is equal to x minus 3. Okay, so that's our first part. Then they say, explain how the graph x minus 3 has changed from the related graph of y is equal to x absolute. So if we were to draw x absolute, let's just see what we get. If you put in -3, -2, -1, 0, 1, 2, 3. And remember this shape. This is a good graph to remember. It's a standard graph. Standard graphs are like the basic or the fundamental graphs. And each graph can be interpreted through this graph. So -3 will become 3. -2 is 2. -1 is 1. 0 is 0. 1 is 1. 2 is 2. 3 is 3. So let's plot these. So let's see what we get. We get our V shape as needed. What do you think has happened to this graph? What do you think has happened? Has it moved in this direction? Sorry. Has it moved in this direction by 3 units? Look at this point. Where has this moved? Over here, right? So it's just slid. So if I slide this graph horizontally, I'll get this graph. So if I have, and look at the two comparisons. So one of the graphs is this. This is your standard. And you want to draw x minus 3. Now there are some things that are similar. This is the same. The only difference, and even this is the same. The only difference is this -3 thing, right? So if it's -3 within the function, not outside it, okay, within the function, then the graph moves opposite to it. So if it's -3, the graph will move +3 units in the x-axis. This is called the translation of the graph. There is a unit on this. We'll work on that part. But this is what is happening right now. Okay? So the graph has moved by +3 units in the x-axis. Look at the two comparisons. Okay, so I attached this graph. So the green graph is hx is equal to half x plus 3, and the blue graph is jx is equal to absolute value of x. So given the functions hx is equal to half x plus 3 and jx is equal to x, which value of x is where they meet, right? So where all do they meet? They meet here and they meet here, right? So what are our x values? Remember, coordinates are written in x and y, and x and y. So we want the x value. Which value of x? So it's either -2 or 6? -2 or 6? Let's go to the answer choices. Let's find these. Do we have -2? Yes, we have. This one's wrong, this one's wrong, this one's wrong. So answer choice is 1. Alright, so we have this, the graphs of the functions fx is equal to x minus 3 plus 1, which is the green graph over here. Fx is equal to x minus 3 plus 1. And the blue graph is gx is equal to 2x plus 1. Okay? Are drawn. Which statement about these functions is true? The solution of to fx is equal to gx is 3. And then the solution to fx is equal to gx is 1. So where do they intersect? Where do they intersect? Right here. So what's the x value over here? The x value is this. We are always looking for the x value. So the x value is 1. This is true. This one is not true. The graphs intersect when y is 1. The graphs intersect when y is 3. Right? So that's not true. And they don't intersect when x is 3. So answer choice 2. Alright, so this question asks us for the minimum value of the function. So what is the minimum value? When we are looking for the minimum value, we are looking for the minimum value of y. So what's the least value of y? Right here, -2. So answer choice 1. So remember this thing, minimum or maximum value is y-axis. And if they ask for the solution or zeros, that is x-axis or x value. Right? So remember these steps. That's going to help you solve a lot of questions. Alright, so we have this situation. So the question is, which value of x, so we're looking for x, results in equal outputs for the two graphs. So there are two graphs. There's jx is equal to 3x minus 2. And then there's bx, which is x plus 2, and the absolute value of it. So we have this black line as jx, 3x minus 2. And the red line is bx is equal to x plus 2 and the absolute value. Now they're saying where are these two graphs equal? So right here, right? Right here. So what's the x value? It's 2. So let's look for 2 and then answer choice. Answer 2. Okay, so we have this situation. The function hx, which is graphed below, so this is hx. And the function gx, so there's this other function gx, which is 2x plus 4 minus 3. So let's plot it, right? Let's put in values and see what happens to it. So let's maybe start with -5, -4, -3, -2. So we can plug in these values and see what happens. So when we put -5, we get gx as -1. And then same with -4, we'll get -3. Then if we put -3, we get -1. And then if we put -2, we get +1. Then -1 becomes 3. 0 becomes 5. So let's plot this on the graph and compare it. So we've got 0, -1, -2, -3, -4, -5, -6. And then we have 1, 2, 3, Ideally, they should have marked the grid so that it would be easy to understand what the graph is talking about or compare. But anyways, let's plot this. So we have -5, -1, -4, -3. Oh, sorry. It's in the negatives. So I'm in the wrong direction. Okay, let's fix this. -1, -2, -3. So -5, -1, -4, -3, -3, -1, -2 is +1, and then -1 is 3, and 0 is 5. So we've got this graph. If we want to draw the line, then we've got this as our graph. So this is gx, this one. Now let's compare. So let's see which statements are true. Right, gx has a lower minimum value, that is true. For all values of x, hx is less than gx. I don't think so. Look at hx. Is it above gx or is it less than? This is less than. So this is false. And then for any value of x, gx is not equal to hx. So are they ever intersecting? They're not intersecting. So are they different values for each value of x? That's why this is true. So 1 and 3 are true. So let's look for something that applies this. Answer choice 2. Let's get this set of values. So x and fx. We are trying to plot this graph. X minus 3 absolute plus 2. So let's put in values. At -1 we get 6. At 0 we get 5. At 1 we get 4. At 2 we get 3. At 3 we get 2. At 4 we get 3. At 5 we get 4. So let's plot these. So -1, 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So at -1 it's 6. At 0 it's 5. At 1 it's 4. At 2 it's 3. At 3 it's 2. At 4 it's back to 3. And then at 5 it's 4. So let's draw the line. So this is the graph. Alright, so we've got to draw the graph for y is equal to absolute x minus 3. So let's plug that in a calculator and see what we get. So if we look at the values, let's make a table. We've got maybe plot from -3, -2, -1, 0. Remember, we've got to show where the curve is, okay? Or the change is. So at -3, it's 6. At -2, it's 5. At -1, it's 4. At 0, it's 3, 2, 1, 0. And then it moves up. Right? So I'm going to plot from 0 to 6 based on these values. So we've got 0, 1, 2, 3, 4, 5, 6. Then we have 1, 2, 3, 4, 5, 6 from this. So at 0 it's 3, so let's mark that. At 1 it's 2, at 2 it's 1, at 3 it's 0, at 4 it's 1, at 5 it's 2, at 6 it's back to 3. So let's draw the line. So we get this graph for y is equal to absolute x minus 3. Now they're saying, how does this graph differ from the standard graph y is equal to x absolute? So let's draw x absolute and see what we get. So let's say we take these values. It's always good to remember this graph. It's a standard graph. So let's plug these values in. Got -1, -2. So I'll draw it in blue so that we can compare. Okay, so they're asking how are the two graphs differing, or how has it changed? Remember this thing that we had a previous question also of a similar nature. And whenever you have a graph like this and you're comparing it with this, look at what's different. So we see a -3, that is the only change, right? The rest is the same as you can observe. So if it's -3, look at where the graph has moved. It's moved in the positive x-axis. Okay? It's moved +3 in the x-axis. So that's what we will write. We will say that the graph of y is equal to x minus 3 is a translation or movement of the graph y is equal to x by +3 units in the x-axis or horizontally. Okay? So that's what we get over here. Alright, so we have this question. Now remember, they've given you the function of the graph. The function is graphed below. And then they're asking for the domain. So remember, the domain is always the range or the set of x values. Let's put it that way so that there's no confusion. Set of x values. So what are the x values that this graph can take, right? Now, the range is the set of all y values that the graph can take. So range is y, domain is x. So what all values can this graph take on the x-axis, right? So that's what we are looking at. Now this point over here is very crucial. They're saying that this is inclusive and this is your starting point. What is this? -1. So anything above -1, and this arrow means that it can go on and on and on and on and on. So if you were to extend this line for infinity, would it keep going on? It would go on. So what they're saying is x can be anything above -1. So answer choice 1. Sorry, 4. Answer choice 4.